Hey everybody, in this video we're going to be using law of sines to find unknown side lengths of triangles. Keep in mind that all the angles in this video are going to be in degrees, so that means if you use a calculator or a computer of some kind to find an approximate answer, make sure that you're in degree mode, because otherwise you will get an incorrect answer. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now, unlike the previous video in the playlist, with this one, we have a triangle that's not a right triangle, but here we can't use law of sines. It's impossible. The reason is we have an angle, but don't know the side that corresponds with it. Here we know a side, but not the angle that corresponds with it. The same there. So that means in order to solve this, we have to use law of cosines. So c squared equals a squared plus b squared. Now it starts off looking like the Pythagorean theorem, but then we have this extra bit on the end, minus 2ab cosine of c. Now c, a, and b up here are all side lengths. They're all lowercase, but this c up here is an angle. So that means that's what we're going to put in for 95. So c squared, that side we don't know. A is 2, so we have 2 squared. B is 3, it's 3 squared. Minus 2, a is 2, b is 3. Times cosine of 95 degrees. And unfortunately, for this problem, we pretty much have to find an approximate value in order to solve for angles A and B. So 2 squared is 4, 3 squared is 9, so that gives us 13. 2 times 2 is 4, times 3 is 12. So we have 13 minus 12 cosine of 95. Now remember, cosine is attached to 12 but not 13, which means you can't put a parentheses around 13 and 12. That would violate order of operations. So we have to type this into our calculator as we see it right here. 13 minus 12 times cosine of 95. So that means c squared is roughly 14.046. So when we take the square root, then that means c is roughly 3.748. But now that we have angle C, side C, now we can find angles A and B. Because now we have a side angle pair, so now law of sines kicks in again. So now we can say sine of 95 degrees over the side that corresponds with it, which is what we just found, 3.748. And that's going to equal sine of A over 2. So when we cross multiply, we're not going to get angle A by itself, we're going to get sine of A, because that's what's up here. And that equals 2 sine of 95 degrees all over 3.748. And so to get A by itself, we're going to have to take arcsine of that whole quantity, 2 sine of 95 all over 3.748. And again, to find angle B, I'm going to have to find an approximate value for A. So arcsine of the quantity 2 sine of 95 divided by 3.748, and we get approximately 32.113 degrees. So now that we have angle A, now we can find angle B, the remaining one. And with this one, all we have to do is say that, well, since we know angle A and we know angle C, angle B is just a matter of subtracting from 180. So angle B is going to equal 180 minus 95 minus 32.113. So that means angle B, subtract that. So angle B is going to be 52.887 degrees. All right. Now for the next one, doing very much the same thing. But this often messes with people because we're not given angle C, we're given angle A. And so a lot of people, they worry about that because when they think of the law of cosines, this is what they think. C squared equals A squared plus B squared minus 2AB cosine of C. But in reality, there are actually three forms of it. And what I tell everyone is I say that these two, the ends, must match. So this is but one form of the law of cosines. So another form would be like this. Well, we have angle A. So let's put cosine of A on this end. So that means on this end we have to have A squared. Well, what's in the middle? Well, B and C. B squared plus C squared minus 2BC. So this is the form of law of cosines we're going to be using for this problem. So A we don't know. Now B is 3. So 3 squared plus 4 squared minus 2 times 3 times 4 cosine of A, which is 30 degrees. So 3 squared is 9, 4 squared is 16, so added together, that's 25. 2 times 3 is 6, times 4 is 24, so we have minus 24 cosine of 30. So now, on our calculator, we punch in 25 minus 24 cosine of 30. And so we get A squared to be 4.215. So when we take the square root of our answer, we get A to have a value of 2.053. So now that we have A, now law of sines kicks in. So now we can say sine of the angle we know, which is 30, over 2.053, which is what we just found. It's going to equal sine of, and I'll choose B, over 3. That's the side that corresponds with it. So to solve here, we're going to cross multiply and divide. So sine of B equals 3 sine of 30 degrees over 2.053. And so if I want B, that means we're going to have to take arc sine of 3 sine of 30 degrees over 2.053. All right, so we type that in. Arc sine of 3 sine of 30 degrees divided by 2.053. And so B is roughly 46.940 degrees. So now that we've found side B, or sorry, angle B, we can find angle C. So for angle C, we take 180 degrees and subtract 30 and subtract 46.94. And so for angle C, we get 103.06 degrees. So now we found the two angles we didn't know and the one side that we didn't know. Now in this final question, describes an airplane that flies due north for 200 miles and then turns 40 degrees to the west, and then flies for another 150 miles. How far away is the plane from where it started? And at what bearing should another plane fly if it wants to arrive in the same destination by flying in a straight path? So we have a plane, so let's draw this out. So it flies north, so it goes up for 200 miles. And then it turns 40 degrees to the west. So this is, here's where it would have gone. And here's 40 degrees. And then it goes for another 150 miles. That's about right. Now the question is, what if instead we had taken a straight line path? That's what we want to know. So this is the triangle that we're interested in. Well, we know that this length is 150. We know this length is 200. Now what about this angle between them? Well, it has to be supplementary with 40. So that means this angle has to be 140 degrees. And so what we want to know is this side right here. So we'll call it C. So using law of cosines, we can figure out this side length, which is the distance from where the plane started to where it ended. So C squared equals 150 squared plus 200 squared minus 2 times 150 times 200 times cosine of 140. Now those numbers are quite large, so I'll just type the entire thing into my calculator. Minus 2 times 150 times 200 times cosine of 140. And so what we get for c squared, quite a large number. We get 108,462.6 repeating. And so when we take that and take the square root of that, we get c to be roughly 329.337. And that answers the first question, because it first asks, how far away is the plane from where it started? 329.337 miles. That answers the first question. Now the next question is, at what bearing should the plane fly if it wants to fly in the same way in a straight path? So the question is, at what angle is this going? So the question is, what is this angle right here? And so this is a law of sines question. So we take sine of 140, the one angle we know, over the side we just found, 329.337, and that equals the angle we don't know, so let's just call that angle A. Sine of A over 150. So when we cross multiply and divide, we get sine of A equal to 150 times sine of 140 degrees over 329.337. And so angle A is going to equal arc sine of 150 sine 140 degrees all over 329.337. And so we'll type that into our calculator. Arc sine of 150 sine of 140 degrees, close off the parentheses, divided by 329.337, and we get an angle A of 17.023 degrees. So that is the angle inside there, 17.023 degrees. The interesting thing, though, is that bearing is always measured from north, and it's always measured measured clockwise. So actually the bearing, whenever you hear the word bearing, that's a very specific word. And so we're actually asking for this angle right there. So to find the bearing, well, that's what's left over in a full rotation, in a full 360. So we'll take 360 and subtract 17.023. And what we do is, when we do that, we get a bearing of 342.976 degrees. That is our bearing, because bearing always measured from north, and it's always measured around this way. So that is the bearing the plane needs to take to follow the first plane. Thanks for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.